Good morning. Thank you for having me. I appreciate everybody coming to visit and you inviting me here. I'm excited to talk about how 3D printing is affecting the toy manufacturing business, toy design and toy manufacturing business. So what I'll start with is first of all, we work with a number, Stratasys is the name of our company. And I'm actually based in Hong Kong, and we have a few representatives here also in Hong Kong as well, present in this forum. And so what I'll talk about today is first some of the challenges that our customers in the toy industry face and how 3D printing interlaces and helps those challenges. And then I'll show some videos and examples of some of our customers in Japan and China and also in Singapore that are using 3D printing in innovative and exciting ways. And after the presentation, if you have any questions, feel free to come and ask myself or anyone from the Stratasys team or any partners of Stratasys as well. So, thank you. So first, I wanted to dive a little bit into what our customers are telling us are the challenges in the toy industry. First of all, a little background on the toy industry everybody is very familiar with, but the largest, fastest growing toy and games market today is in China, based on a study done in 2014 by Euromonitor, which is a consultancy group that does research on industry trends and insights. And some of the market trends in the toy industry that our customers have been telling us and also are affirmed from this study are that there's an increase in desire for companies to license toys, toy brands and toy design. The second main trend is that there's a demand for higher technology with increasing requirements for electronics. The third trend is that there's the customized market, as Mr. Chan mentioned, and collector's items market is still growing very strongly, and we'll see some examples of where 3D printing fits for this market as well. And then the last trend is there's increasing competition in the toy industry, and so there's an increasing pressure on designers and manufacturers to integrate many value-added components or features into their toys to separate themselves from the competition. I may be going a little fast for translation, I'm sorry. I'll maybe slow down a little bit. So, some other insights. The global toy market in terms of exports, China is the largest global toy market exporter globally. Takes up 42%, 43% of the global exporting of toy manufacturing. And then also, considering that we are in South China, Hong Kong, this is the largest market or distribution of toy exports in China altogether. So I believe toys is a very, very crucial, very important industry to both Hong Kong and South China. And I know I'm speaking to everybody here, everybody's aware of this, but it's definitely a very large focus area for this market specifically. So some of the challenges, when we look at the first challenge that I mentioned or talked about was that there's an increased need for advanced technologies being integrated into toys. And so we can take a sampling of children years 12 years old and under, and take a look at the advancement in the technologies and the consumer demand on the technology front. So if you look, there's an increase, and I expect this to continue to grow, an increase in requirement for game consoles or touch screens and more electronics and advanced technologies to be integrated into toy design. So traditional toys used to look like this when we were growing up, and now toys are starting to take on a much more modern approach with drones, automation, a number of different technologies invited into this. And this presents a challenge for toy manufacturers, toy designers, to really stay on the cutting edge in terms of technology and toy design. Additionally, another challenge, specifically in China, is if we look over the last few years, there's a steady trend of increase in labor costs, hourly wage. And so this presents a challenge for toy manufacturers. As the wages increase, toy manufacturers and designers are forced to find ways of cutting costs, ways of improving their processes, and 3D printing fits very well into this, trying to make design processes and production processes more efficient. That's the main goal of 3D printing, and we'll see that later on the presentation. So, with that, that's a little background into the toy industry from our perspective and what our customers are saying. I have a number of case studies. I'll share a number of different opportunities and applications for 3D printing, specifically in both the product development and engineering side, and then also in the manufacturing side. And I'll share a number of cases from large toy companies in Japan, like Bandai and Tomy, that are using 3D printing in innovative ways as well. To look at where 3D printing fits in the product development and engineering process, there's a number of things that happen in this process of designing new toys. First, we have market research, where local industrial designers, local product designers will actually base sketches, engineering drawings on the local demand, local requirements. So this is an example of a Gundam sketch that's an industrial design, that this is where the entire idea of a product begins. In this stage, 3D printing can really help these designers to quickly iterate through initial concepts. And you can see in this example right here, this is a quick completely white model that's been printed to test whether the market would demand this type of product, or if there needs to be slight changes or modifications to the product. So initially, 3D printing fits in this area. Now, going more into the detailed design, you can see we've added colors. Using Stratasys 3D printers, we're able to print colored models. We're able to kind of skip the step of painting parts, which is very common in industrial design and model making as well. So this has been printed with color, and we also have a number of solutions for full color as well, so that industrial designers can get a very realistic prototype very easily and effectively without having to without having to paint models and go through a paint shop as well. Then kind of moving into the product development, the detailed design work, where there's a number of maybe joints or movable components. This can be a very complicated area for engineers to work with. And if you're working through traditional processes, it can take a long time to get prototypes and actually test fitment of components and ensure that components fit together correctly. And then also, another area, this is an example of drop testing, and a number of kind of dovetailing into certification and certification planning for safety. 3D printing can really help companies to, there's a number of instances where they can actually do drop testing in addition to the engineering validation testing, and then also use printed tooling or printed molds to create initial samples for safety testing, compatibility testing under a number of different certifications. And then finally, another area that 3D printing fits, talking to some of the toy manufacturers in China and in Japan, it can really fit to help enhance your marketing of new products and new product development. So these are some examples of some 3D printed toys that are prototypes that have the full color. This is from Tomy. And then also have the packaging as well, so you can introduce this to a market, into your market at a trade show or something like that very, very quickly before making the high investment in tooling or something of that nature. Sorry. Okay. So diving into some of our customers that are using this, specifically from Japan, the Bandai Hobby Center, which is actually in charge of the Gunpla models. all planning, design, prototyping, and production. Misspelling. But anyway, this center is in charge of all of the aspects of product development for the Gunpla models. And you can see their facility is very high-end, very advanced, and they have a 3D printer right in the middle to do a number of things. They actually own an Eden 500V, which is one of the Stratasys printers. What 3D printing enables them to do, and this is actually on their website, and they're very, they share a lot of information about this. It enables them to prototype much faster, which gives them three primary benefits. It synchronizes their design and production process so that those can happen at the same time rather than waiting for a design to be finalized to actually produce parts, extending your product development cycle. The second thing is that it actually helps reduce the number of schedule delays caused by molding rework. So this is another way it can provide faster prototyping to their development process. And then prototyping time overall can be reduced significantly so that many iterations can occur very, very quickly from days to hours. So rather than waiting on a supplier to supply prototypes or something of this nature, they can print them all in-house in multiple iterations at the same time and are able to iterate much quicker. The second main benefit is it provides Bandai with a lot of flexibility in their production process. So this is an example of where a number of these components are very complicated and have movable components, and 3D printing allows them to check the interference, fit, and fitment of all of these components very, very quickly, and also produce customized parts. Under the Bandai name, we also have Tamashii Nations, which is a collectible item, toy item out of Japan for a number of anime series and other types of toys. And so this division of Bandai actually uses 3D printing with traditional processes as well. They kind of outline their entire process. It starts with a basic design template, which they have the original design here. It's basically a standard body design. And then they add all the features in for a number of different designs or a number of different, they use a model maker will actually sculpt into clay and create the general look and design aspect of the toy. And then they'll use a 3D scanner to convert it to digital data. And then where the 3D printing actually comes into play is when they're testing the fitment of some of the complex geometries and stuff. And so this is an example of where they integrate the joints and complex moving components and use a 3D printer to print these out and test the fitment, et cetera. And then if they have any adjustments, they can quickly redesign it or adjust the interference tolerances in CAD and reprint those designs same day or in one day to get an updated version before going into molding. The next company, actually, I'll be talking a little bit about Swanee, which is a smaller company in Japan, but they really have taken on 3D printing in a very innovative way, and they've worked with a number of different companies to do a number of different things in 3D printing with toys specifically. So this is a joint project with Swanee and Takara Tomy, and they actually did an expo at the DMS Design Manufacturing Solutions exhibition in Tokyo last year, where they showed their metal injection molding, metal forming and injection molding processes with 3D printing. So this is taking the product development process to the next step, right? Everybody's kind of familiar with concept modeling, interference, fitment checking, those types of things. But Swanee is taking it to the next step where they're actually prototyping their tooling very, very quickly. And I believe in this market as well, there's a lot of opportunity to do this in a much more efficient and effective way. Some of the benefits this enables Tomy is to get a quicker turnaround time on their prototypes. It minimizes their product development costs because they're spending less on 3D printed tooling rather than production tooling with reworks. It also enables them to prototype more complex models more frequently, and then reduces their mold development time by 40%. So these are all figures from Takara Tomy and how they use 3D printing. And you can see this is the exposition they were showing. These are some metal injection or some metal sheet metal formed parts that they use a 3D printed mold to actually metal form the parts, compressing their design time for these specific components. And here is an example of where they're using 3D printed tooling for injection molding as well. So talking a little bit about Swanee. Swanee uses, they call it the hybrid molding system. So they use a mix of aluminum and printed parts to prototype parts very, very quickly. Typically, they can use this method of prototyping for low volume production pieces up to 500 parts and can go from design to mass production in about 6 days, is what Swanee has quoted on a number of projects they've worked on. They'll use aluminum molding for the complex, really deep draw features or difficult to pull out components and areas of a mold. And then they'll use the digital mold for the cavity and then simple features that would cost a lot more to machine rather than printing. The benefits with this is that it gives them a significant reduction in cost of their product development process, and then also enables them to realize a short delivery time to their customers, their customers being toy manufacturers, toy design companies as well. So you can see some of the examples of traditional milling for aluminum prototype molds, which sometimes this happens, sometimes it does not. It depends on the company structure and the complexity of the design. And then the exact same design that's printed with 3D printing in an hour or a couple hours as compared to something that's machined and takes a lot longer to get from a vendor or in-house higher labor costs. And then it's actually placed in the injection molding mud set, and parts are molded from there. And so one example of this is this product is a very low volume customized product where they were actually able to create the runner system and some of the detailed designs for a customized product with 3D printing. They can change the design on the fly, and they're able to adjust and improve the product or make slight modifications to target different markets and whatnot. So I wanted to show you a video from Swanee's website on this. And there is sound, but, oh, my bad. There is sound. I'm going to mute it. It's just very loud music. So here you can see is the mold design in CAD. They actually 3D print them, and they can print multiple iterations at the same time. And we do this here in Hong Kong as well. We print multiple iterations with slight modifications in the design to overnight, so that the next day you can quickly clean them and set them up on the injection molding system. This is a boy injection molding system. A baby plast injection molding system, but it's a small injection molding system that enables them to quickly prototype parts with 3D printing. So this is an example of their production product development process. You can see some of the example parts that have been injection molded. The second company they've been working with is Castem, and they've actually been doing low volume metal injection molding. So they're kind of extending the applications for 3D printing, kind of pushing the technology to its boundaries. Low temperature metal injection molding is still very high temperature compared to plastics, but for very small batch production parts or small batch test parts, maybe die cast models or something like this, it can be a good fit for certain geometries and certain applications. Stratasys has a number of customers that are doing this, and we have a lot of experience with telling companies whether we can or cannot meet the requirements for this specific application. But you can see some of the metal injection molded parts that come off of 3D printed molds as well. And then the last one they're actually working with Custom on is for sheet metal forming. As we saw in the Tomy case, where they sheet metal formed a car prototype mock-up for marketing purposes. These are some examples of how Tomy is using printed molds. The green molds are the printed molds to create sheet metal formed parts with complex textures that would take longer to create traditionally. And I have a video to share. It's a quick one. But you can see this is the 3D printed mold. The top half is also a 3D printed mold or die, and they're able to get quick iteration parts very, very effectively with varying gauge thicknesses, etc. To show some more examples of some of the parts that they've done. And we actually have in our demo room in Hong Kong, in Kwun Tong, we have a small sheet metal forming machine that we can quickly make prototype parts with. Relatively small size, but we can share or show anybody who's interested in this type of application how it works with 3D printing as well. So diving into some of the manufacturing applications, there's three primary areas where 3D printing fits. For design and manufacturing new product introduction communication models, for assembly and processing fixtures, and then also for customized product manufacturing. Sorry. So this is an example from the electronics industry, but we also have toy manufacturers doing this as well. Since there's an increase in design requirements, an increase in technology requirements, it can be very beneficial for complex assemblies to be printed for new product introduction. This is an example of Microsoft Surface tablet. They printed over 300 prototypes of their first revision of the Surface tablet between their two engineering and manufacturing teams. So they have an engineering team in Seattle in the US, their design team, and then they have an engineering team for production in China, where the actual production is happening in South China. So what they're able to do is print the exact same model in both locations to hash out or solve some of the complex issues that happen when introducing new products to an automation line. And so they printed over 300 prototypes, slight design modifications to test assembly fitment, to test automated assembly processes and manual assembly processes as well. Additionally, they were working with their design teams on future products, not just the current release product, but also the next 4 generations simultaneously as their first generation. So it enables the manufacturing team to get a much better view of how to create higher automation, more efficient manufacturing processes around newer and later stage products. Also, with Microsoft, there's a number of, in their, some of their design or their manufacturing facilities in China, they have a number of manual assembly processes and automated assembly processes. 3D printing can really fit in manufacturing tooling to create customized fixturing, customized tooling for better production output and higher quality products, less scrap rate, etc., and potentially improve overall cycle time as well. And so we have a number of engineers here in Hong Kong and in South China that have a lot of experience with working with manufacturers to create fixtures that enable manufacturers to produce more products more effectively. And so these are some examples. This is an example of a wire harness assembly jig. It's a manual process, but they're able to print out a custom assembly jig that traditionally they wouldn't have a fixture, or the fixture could potentially not be optimized for the actual assembly process. Additionally, this is an example of a mouse assembly fixture where they actually take the CAD data correctly, or exactly the CAD data, and basically, very simply, just design it into a block that they can simply print the exact contours of the mouse, which enables them to assemble and solder different components and electronics into the mouse much more effectively. So these are some simple manual tool examples, but we have a number of examples that we're working with toy manufacturers as well as the contract manufacturers in China also. And then on the automated production line, there's a lot of engineering work that goes into these as well, and specifically automation, end-of-arm tooling, automation, rails, guides, these types of things. So these are some examples of some 3D printed tooling that has been optimized for the specific process and helps save weight on automation and robotics, helps improve efficiency, and also improves or reduces the design cycle time required for the automation equipment. So these are some other examples of where 3D printing fits for manufacturing specifically. So the last example I'll share is around drones, specifically Nanyang Technological University in Singapore is doing some advanced research, and we also work with a lot of drone companies at Stratasys, specifically with our FDM technology. But this research university is investigating a way to use the 3D printer to fully embed all the electronics and create custom drones directly, fully assembled directly out of a 3D printer. And so they're using some very unique and innovative technologies to actually assemble the 3D printer or assemble the drone in the 3D printer and then take it out after it's been completed and automatically continue production with slight modifications, customization, a number of different things. So you can see the 3D printed drone here. And to leave you with a last video, is the drone actually flying? There we go. So they're printing this with our Ultim 9085 material, which is a FAA compliant material for interior components and also for flight safety regulations. And then they integrate all of the electronics, motors, etc., into the part in the 3D printer. And then you can see the example of the final drone quadcopter flying with 3D printed components, fully assembled in a 3D printer. So, with that, these are, that's what I have today to share. If you have any questions, feel free to ask me afterwards. If not, I look forward to speaking with everyone individually. Thank you.